So Unit 4, Lesson 5 is complex numbers. When we're looking at complex numbers, is a number that has both a real and an imaginary part. So it'd be something like 5 plus 6i, negative 2 minus 12i, negative 6 plus I. Anything with a real and an imaginary part is a complex number. And so when we're looking at working with it, we're going to first start with adding and subtracting complex numbers. And really this goes back to combining like terms. So you look to see what real parts can combine. Well, we have a negative 11 plus 9. So negative 11 plus 9. And then we look at our imaginary parts, same idea. Positive 3i plus 2i. And so when we do that, we end up with a negative 2 plus 5i. And we're done. That's the solution. So again, it's just combining the like parts. So doing this next one, the same idea. 4 plus 7 and positive I plus negative 5i. So positive I plus and negative 5i. So when we add our real parts, 4 plus 7 gives us 11. And then when we add our imaginary parts, 1i plus a negative 5i gives us a negative 4i. So going on to a little bit more complicated of ones, or we have subtraction or we have multiple operations. And it's going to work the same idea. You're going to take your real parts. So our real part is 7 minus 2. And then our imaginary part, negative 2i minus a positive 6i. So when you're minusing a positive 6i, it's just like subtracting. And 7 minus 2 is 5. Negative 2i minus 6i is negative 8i. And that's it. On number 4, we have more than that parts, but we're going to still go the same idea. We're first going to look at your real, but we have this negative sign in front, and so that's going to go to both parts in this parenthesis. So we have a negative 14 plus 5. Now let's do the imaginary. 6 minus 6i, and that was a positive 6i, so plus, minus a negative I, plus negative 3i. These signs combine and become positive. These signs combine and become minus. So we have negative 14 plus 5 is this negative 9. And then on our imaginary parts, we have 6 plus 1 minus 3. And so that would give us 4i. So again, on the adding and subtracting, it just behaves like you would when you're working with combining like terms like you did back in 7th, 8th, 9th grades. It just, our second variable is the I, the imaginary part. When we're multiplying with complex numbers, it's going to again behave just like if this was a variable. And so you're going to distribute that 2i to both pieces. So 8 times 2i minus 3i times 2i. So 8 times 2 is 16. That's the only I, so I put 16i minus 3 times 2 is 6. I times I is I squared. Now we have an I squared. So I squared becomes -1. Going back to remembering how we worked last time. So I squared, anytime you see that, you can replace that with a -1. And so we have 16i minus 6 times -1. 6 times -1 is going to make that a +6. But this is not the way to write it. Anytime you have a complex number, you're always going to do real, and then you're going to either add or subtract your imaginary. And so our real has to go first. So our real and our imaginary parts. So you do 6. It's positive because this is positive. And the 16 is positive, so you put a plus 16i. Do you have to write this positive here? No. So let's do number 6. We're going to distribute a -i to both pieces. Negative times a negative makes it a positive 2i. Negative times a positive makes a negative 10i squared. So that I squared showed up back up. Anytime we say an I squared, it becomes -1. So we have 2i minus 10 times -1. And you may not need to show all these steps. I'm showing it to you so you can see where all the things are coming from. When you multiply -10 times -1 becomes a +10. But this isn't in the right order. We need to move our real first and our imaginary second. So our real is +10, our imaginary is positive 2i. So when it's just a monomial in front of the parentheses, all you're doing is distributing. Nothing different than when you had to work with variables, except for anytime you have that I squared, you have to convert it into a -1. Or if you have any higher powers, you have to convert those as well. And so we're going to look at these. Again, we're multiplying. And there are multiple ways to learn to multiply. I'm just using the box method because it seems to be the easiest method for most people to grasp. And so you put the factors on the outside and the product on the inside. And so if you're starting with the factors, they're going on the outside. If you're trying to factor, you're trying to come up with the outside. And so 4 minus I. 7 times 4 is 28. 4 times a positive I is 4i. 7 times a negative I is a -7i. And then we have our -I times positive I, which gives us -I squared. So that I squared showed back up. That becomes -1. So you have still that negative from the problem. So a -1 becomes a +1. And you're going to add the diagonals. Diagonals should always combine. So here we have 28 plus 1. And on our other diagonal, we have -7i plus 4i. And so for our real part, 28 plus 1 is 29. For our imaginary part, -7 plus 4 is a -3i. And then we just go ahead and write that as our answer. 29 minus 3i is your answer. So as again, you're looking to see combining real parts, combining imaginary parts, but it's only after you multiply. So let's look at the next one, similar idea. So when we have the two factors that we're multiplying, go ahead and write your factors on the outside of the X, or outside the box. And so we have 2 minus 4i and negative 5 minus 3i. We multiply coming in, so negative 5 times 2 is a negative 10. Negative 5 times negative 4 is a positive 20i. Negative 3 times 2 is a negative 6i. And negative 3 times negative 4 is a positive 12i squared. We have that I squared, so that means automatically we know we need to take and change that to a negative 1. And so we have a positive 12 times negative 1, which is a negative 12. So when I add my real parts, I have negative 10 minus 12. And when I look at my imaginary parts, I have a positive 20i minus 6i. And so negative 10 minus 12 gives me a negative 22. A positive 20 minus 6i gives me a positive 14i. So on number 9, you have 6 minus 2i squared. And so that means you're going to write 6 minus 2i on both sides, and that's what you're going to multiply. 6 times 6 is 36. 6 times negative 2 is negative 12 times I. 6 times negative 2 is negative 12i. And that gives us positive 4i squared. Well, we discussed that I squared is negative 1. Because every time we see an I squared, we're going to write a negative 1. So 4 times negative 1 is negative 4. So when I add this diagonal, that gives us 36 minus 4. Then we look at the other diagonal, negative 12i minus 12i. And that combines to give us negative 24i. And we have 36 minus 4, which is 32. And so when we write it in the best form, which is the imaginary last, it ends up being 32 minus 24i as your answer. Let's do one more of these. And this one we're going to add in a couple of extra steps. So we have to think about the order of operations. The first thing you need to do when you're doing these is the multiplication. And so we're multiplying these two first, and then second, we are going to subtract. So let's go ahead, and with multiplication, we use the box. So 1, 7i, 9, 3i. And we're going to multiply going in. And so 9 times 1 is 9. 9 times 7 is 63i. 3 times 1 is 3, and it has an I. 3 times 7 is 21, and we have an I squared. So we have an I squared, so the next step is to take and change that I squared into a negative 1. So 21 times negative 1 is negative 21. So we have 9 minus 21 and a positive 3i and a positive 63i. So when we do 9 minus 21, that gives us 12. And it would be negative because the 21 is the larger of the two numbers in magnitude. And then we have our 3 plus 63, and that gives us 66i. So let's go ahead and write this up here. 12 plus 66i. We're taking this and then we are going to subtract from it a 4 plus 2i. So we're going to look at combining our real parts and our imaginary parts. So our real, negative 12, or minus sign, 4. So negative 12 minus 4. Now let's take and get our imaginary parts gathered together. And a positive 66i minus a positive 2i. And we have negative 12 minus 4 is negative 16. And then on our imaginary portion, we'd have positive 66 minus 2, which gives us a positive 64i. And we are done. So now let's look at the next step, which is complex conjugates. Complex conjugates are two complex numbers where they are exactly the same except for the middle sign is opposite. And anytime you have the product of any two conjugates, it's always going to result in a real number. And so that means there's not going to be an imaginary part. And so let's look at multiplying these complex conjugates. And we have 8 plus I, and we're going to write that on one side, and then 8 minus I in the other. So 8 times 8 is 64. 8 times I is 8i. Now let's do the next row. Negative I times 8 is negative 8i. Negative I times I is negative I squared. And so we talked about that. Anytime you see an I squared, take that I squared, you mark it out and put it as negative 1. And so if we take in what we originally had, which was a negative I, so that makes this a positive 1. So we have 64 plus 1. And now let's take our imaginary part, and that's a negative 8i and a positive 8i. These should always cancel out. If they didn't, you did something wrong, so go back and double check. If you're multiplying complex conjugates, they should always cancel out. And so that leaves us 64 plus 1. So our answer is 65. So again, anytime you're multiplying complex conjugates, your imaginary part will cancel out and it will only leave you with real answer portion. Let's do another one. So again, 3 plus I, 3 minus I, we multiply coming in because we put the factors on the outside and the product on the inside. Negative I times 3 is negative 3i. Negative I times I is negative I squared. I squared, anytime we see that, we change it out and place it with a negative 1. And so if we look at what we had originally was negative I squared, so it would be a negative negative 1, which is a positive 1. So our real part is 9 plus 1. Our imaginary portion is negative 3i plus 3i. These cancel out, leaving me just with my real portion, which is 9 plus 1, aka 10. So 10's my answer. Let's do a couple more where we have something besides an I at the end. So let's look at this one. Start off the same way we did. Put your two factors on the outside because we're going to do a product. So we're taking the factors in. So 5 times 5 is 25. 5 times negative 4 is negative 20i. 4 times 5 is 20i. 4 times negative 4 is negative 16i squared. And so now we take and we see an I squared. So anytime you see an I squared, you cancel it out and make it as a negative 1. So we take what we originally had in that square, so negative 16 times negative 1 is a positive 16. So now we add our real parts, 25 plus 16, and we combine our imaginary, a positive 20i minus 20i. Those cancel out, so we know we did it right. And we have 25 plus 16, which is 41. So 41 is our answer. So when we're looking at 14, again, we're taking and multiplying conjugates. So we're going to multiply with the conjugates out here. So we put the factors, negative 7 plus 2i and negative 7 minus 2i. We multiply coming in, and so that gives us 49, negative 14i. Negative 7 times negative 2 is a positive 14i. And then negative 2 times positive 2 is a negative 4i squared. And so that I squared becomes a negative 1. We're taking right up that negative 4 times negative 1 is going to equal a positive 4. So now we have 49 plus 4 as our real numbers, and our imaginary numbers are positive 14i minus 14i. And again, since we're multiplying conjugates, these will always cancel out. It's always good to double check it to make sure you did everything correct. 49 plus 4 is 53. And so that's our answer, 53. Now looking at solving equations with complex solutions. So yesterday we just had imaginary solutions, but today we're going to have complex solutions. And so it's going to start very similar. You're going to get your squared term isolated first. And so our squared term is right here. We have x plus 2, that quantity squared, so it's isolated. Then you take the square root. We see that we have a negative, so we know we have an I. We took a square root, so we know we have plus or minus. Those are automatics. We're left with the x plus 2 from what was under this inside the parenthesis. And now we're going to take that 81 and take the square root of it. Well, the square root of 81 is 9. So yesterday, that's as far as you would have to go because it was done at that point. Today, we have to get that 2 moved over. So minus 2, minus 2. And so we end up with x is equal to negative 2 plus or minus 9i. And if I ask you to write in set notation, that's whenever you take and put the set brackets around it. But if I don't, you don't have to. Let's do another one that's at that level. So again, we take and we have the squared term by itself. So the first step is going to be taking the square root of both sides. Because we took the square root, we automatically know we have a plus or minus. Because it's negative underneath it, we know we have an I. And we write, we took the square root over here, so x minus 6 is what's left whenever those cancel out. And we take the 32, we look for the largest perfect square number that can divide into it. So when we're looking at those perfect square numbers, we're looking at 1, 4, 9, 16, 25, etc. So 16 is the largest perfect square that can divide into 32 evenly. So square root of 16 times square root of 2. Well, the square root of 16 is 4. Square root of 2 is 2. Square root of 2. So we can't take that square root, so it just stays as is. So now we need to take and move the 6 over to join the imaginary portion. And so we have x is equal to a positive 6 plus or minus 4i square roots of 2. And our answer is done. So in number 17, what we see is different on this one is we have our squared item over here, but there's this -1 in front. And so we have that negative that we need to get moved to the other side. So to do that, you would end up dividing both sides by -1. And so we have x plus 4 is equal to a -75. Now to get rid of the squared, I take the square, oops, that's still squared. To get rid of the squared, I take the square root of both sides. And I end up with x plus 4 is equal to, and anytime I take the square root of a number, that means I'm going to have the plus or minus sign. Since that number is negative, that means I have imaginary. And so I'm going to take that 75, and I'm going to look and see how can I split that 75 apart into its perfect square times a number. So 25 times 3 is equal to 75. I can take the square root of 25, and that's 5. And the square root of 3 is square root of 3. Now I need to move that 4 to join the right-hand side, so subtract 4 from both sides. And I have x is equal to -4 plus or minus 5i square roots of 3. And so that's that answer. We've got 2 more problems we're going to work with, and I want you to focus in on realizing that these two have both have fractions. And so when we're dividing by fractions, oops, got ahead of myself, sorry. This next one just has a 2 in front, so we divide both sides by 2. And we have what's left is x minus 1 squared is equal to -28. Now we're going to take the square root of both sides. And so when I take the square root, that automatically gives me a plus or minus. It's a negative under the square root, so I automatically have an I. And so I'm going to look at 28, and I'm going to see what are the perfect squares that can divide into 28. The largest perfect square that can divide into 28 is 4. So square root of 4 times square root of 7. Square root of 4 is 2. Square root of 7 is square root of 7. And on our right-hand side, we still have the x minus 1, because those a square to the square root cancel each other out. So I now need to move that -1 over to the right-hand side by adding 1 to both sides. And so x is equal to 1 plus or minus 2i square roots of 7. These last two have a fraction that's being multiplied in front of them. And remember, when you're dividing by fractions, you're multiplying by the reciprocal. So the reciprocal of -1/2 is a -2/1. that we're going to multiply both sides by. And negative 2 over 1 is the same thing as negative 2. That cancels out on the left-hand side, leaving us with just x minus 7, that quantity squared, is equal to 54. And that would be a negative 54 because we have a 1 positive, 1 negative. So I take the square root of both sides. Anytime I take a square root, that automatically gives me a plus or minus because that square root is negative. That number I'm taking the square root of is negative. It's an I. And so I have on my left-hand side x minus 7. The number I am trying to simplify under the square root is 54. So I'll look for the largest perfect square that can divide into 54, and that's 9 times 6. So the square root of 9 is 3. Square root of 6 is the square root of 6. Now I need to move the negative 7 over to the right-hand side by adding 7. And so x is equal to 7 plus or minus 3i square roots of 6. And that would be your final answer. And last problem, again, we have a fraction as the multiplier. And so to move that fraction over to the other side, we would have to divide by 3/4, which when we divide by a fraction, we multiply by the reciprocal. So we're multiplying by 4 over 3. And remember that negative 96 is over 1. We look to see what we can reduce in our diagonal. So 96 and 3 are both divisible by 3, leaving us with a negative 32. And when I take 32 and negative 32 and I multiply it times 4, we end up with negative 128. And we still have the x plus 3, that quantity squared, on the left-hand side. So now I have my square root isolated. So I take and square root each side. Or I have my square isolated, so I square root both sides. And with x plus 3 is equal to, well, I have a negative I took a square root of. So that automatically make sure I have an I. And since I took the square root of both sides, that means I have a plus or minus that showed up. So I'll look at 128. And the largest number that is a perfect square that can divide into 128 is 64 times 2. Well, the square root of 64 is 8. Square root of 2 is square root of 2. Now I take the negative 3 and I move it over to the right-hand side by subtracting. And I have x is equal to negative 3 plus or minus 8i square roots of 2.